Hello and welcome to the third lecture on precalculus. In this lecture, we're going to go over graphing parabolas, standard form, vertex form conversion, the vertex itself, axis of symmetry. Then we're going to move on to completing the square and quadratic formula, two methods of quadratics, and then we're going to end talking about complex numbers and solutions. Now, to begin today's lesson, I want to revisit you all to the quadratic graph, y equals x squared, that we discussed in a previous lesson. If you recall, the shape of that graph kind of looked like that. It was a even shaped U curve with y-axis symmetry. Y-axis symmetry. You might not remember that, but it has y-axis symmetry. And what we did was, when we changed this point, all we had to realize to adjust this was that the single point, the end, had to just be moved up 3 points, and then everything else stayed relatively the same. And if we were to change a different if we were to change it in a different way, y equals x minus 2 squared plus 3. If we were to do that, then our equation becomes a matter of moving 2 up and then 3 up, and then our equation is the same. Now, that point is the one thing that is getting changed every now and all over the place, and that point has a special name. We call that the vertex. And this equation, which gives the vertex, which gives the point at which we're supposed to graph everything else with, it gives it very easily. So we call this the vertex form of the equation. And a vertex is useful because it's either the topmost or the bottommost point on our graph. For example, if we had y equals negative x squared, x minus 2 squared plus 3, then the graph would be the same. The vertex would be the same because it would be negative 2 up 3, and it would point downwards because it's a reflection over the x-axis, as you recall, because it's over there. And here now the point is the highest. That's still the vertex, but the point is the highest versus the point being the lowest. So the vertex is very, very useful in that aspect. So by finding a vertex, we can find out the maximum point the function will go to, as well as the minimum point the function will go to, which is why the vertex form is so important. But as we know from algebra class, the vertex form doesn't put the equation in the most simplest of terms. The simplest of terms is actually in something called standard form, which we must get to now, which is what we'll do by doing algebra. X minus 2, we'll put that twice because it's being squared, multiply to each other, plus 3. And I'm not going to take any shortcuts here because I don't want to assume that you've taken any algebra or done anything crazy with algebra class or recall it. Minus 2x, so it's minus 2x, minus 2x, minus 2x, plus 4, plus 3. And we simplify that out once more. X squared minus 4x plus 4 plus 3, plus 7. Excuse me. How about that? This doesn't look anything like the previous equation. It doesn't have any of the numbers, but it's still the right form of the equation, and we call this standard form. It's written in the simplest of terms. It's not the best thing for finding our equation, but it's still pretty good. So let's go back from standard form back into the vertex form. How do we do this? We can graph it and try to find the vertex that way, but the better method is by doing something called using the vertex equation, which is very convenient. It's v of x equals negative b over 2a, and this basically means the x-coordinate of the vertex is given by the equation negative b over 2a. Now, negative c over ba only makes sense if I tell you that the standard form is actually written in ax squared plus bx plus c format. So some constant times ax squared plus some constant times x plus c. So our constant that's being multiplied, our b, is actually negative 4. So opposite of negative 4 is positive 4. 2 times a is 2. Our vertex, our x-coordinate is actually 2. And then we put that back into our equation. 2 squared is 4. Putting in this equation to find the y. 2 squared is 4. 4 minus 4 times 2 is minus 4 times 2. 4 times 2 is 8. Plus 7. So 4 minus 8 is negative 4. Negative 4 plus 7 is 3. So our coordinates for the vertex should be 2, 3. Well, that makes sense, right? 1, 2, 1, 2, 3. Huh. But we have our vertex. We found the vertex. Let's put this into vertex form. Well, the vertex actually has the opposite of the x-coordinate and then just adds on the 3. And that works out because of the way the translations work. So let's just use that back into our situation here. So y equals the opposite of that x-coordinate of the vertex plus 3. And that looks exactly like the thing we had over there. And we can go interchangeably between the two back and forth as we will. We found the vertex, and if you notice, there seems to be a certain type of symmetry that exists in this graph. Let me draw that again. 2, 3. Both ways are kind of, if you could cut the graph like right there, then it looks like these basically are the exact same exact same shape. God. So that is known as the axis of symmetry. The line at which when we cut it in half looks exactly the same. And that's basically just your x-coordinate, which we found to be 2. The vertex is 2. The x-coordinate of the vertex is 2. So could we just write 2? No, we have to give an equation. So the axis of symmetry is x equals 2 for all values of 2. It's not y equals 2. Why is it not y equals 2? Because y equals 2 goes this way. X is this way. So our axis of symmetry is y equals 2. Our equation is y equals x minus 2 squared plus 3. And that appears to be everything on this chart. If I remember something later on in the lecture that I want to cover, I will cover it, but as far as this is concerned, this is basically it. Next, we got to learn two methods for finding finding this vertex form as well as solving a quadratic equation. First, we're going to talk about vertex form. Let's go back and let's find an equation in vertex form. Let's see. Let's say, let's actually put it in standard form. Y equals x squared minus 6x plus 13. I was incorrect by saying put it in vertex form. I actually should have said put it in standard form because completing the square is used to go from standard form into vertex form. And then it can even be extended to go into to solve for the equation, which is what we're going to do right now. So the first things first in completing the square is we're going to want to isolate the term, temporarily move anything that doesn't have x in it over to the other side. So that becomes that. Now what we do is we do an equation called 1/2 b squared, which means basically you take half of the b term, which was -6, which is -3, and square it, and -3 squared is 9. So we add 9 to both sides. So x squared minus 6x plus 9 equals -13 plus 9 is -4. Right? -13 plus 9 is -4. But this creates a perfect square trinomial. X minus 3 squared equals -4. How about that? It creates a perfect square trinomial. So now all we have to do is move our 4 back over to the other side. So we add 4 equals 0. Well, let's just put that as y. And then suddenly we have our vertex form right then and there. X squared plus 4. So this is another method. Completing the square and vertex formula. V of x equals -b over 2a. Those are two ways we can solve to find our vertex form. And then from vertex form, it becomes a simple matter of graphing. Now, I want to warn you all against looking at something in a certain way. We need to ensure that we don't view positive 4 as the y-intercept. To find the intercept of these, we just to find the intercept of this find the intercepts, sorry, of this parabola, we have to first graph it. Just follow me on here. So we're going to do +3 up 4 right there. It's going positive. Does it look like it's going to intercept the x-axis at any point? Well, we know that the vertex is the lowest or the highest point that a function's ever going to go to. So, no. It's never going to intercept the x-axis. So there's no x-intercept. But is there a y-intercept? Yes, there is. Eventually it's going to be. Actually, in standard form, excuse me, our c will actually be our y-intercept. That's very interesting, right? Now let's go a step further. Let's say I wanted to take this one step further and I actually wanted to solve an equation. I don't want to use this one quite yet, but I want to do something else. Let's say that I wanted to solve an equation x squared plus 7x minus 2. I wanted to solve for it. Now, you might remember factoring. Factoring is one way to solve it, right? But there's no factors for this, so we have to use either completing the square, which I'll show you how to do in a little bit, or we can do quadratic formula. We're going to try quadratic formula first. Negative b plus or minus, you might remember this. This is the quadratic formula. It can be used to find all the x coordinates. They will find the x intercepts, and the x intercepts are treated as the solutions to the equation. So what we do now is we put our variables in. So negative b, opposite of 7, plus or minus the square root of 7 squared, which is 49, minus 4 times a, which is 1, times c, negative 2. So 4 times 1 is 4. 4 times negative 2 is negative 8. 4 plus 49 plus 8 all over 2a. And it becomes 2. So then that becomes negative 7 plus or minus the square root of 49 plus 8, which is 57 over 2. And then it goes into negative 7 plus the square root of 57 over 2 is one solution. And then negative 7 minus the square root of 57 over 2 is a solution. Notice the plus or minus. And that makes sense because, as you're going to learn later, a fundamental rule of algebra, the fundamental theorem of algebra, states that the number of solutions of equation is given by the degree. So we should have two solutions to this equation. I'm going to show you how to do this in the completing the square method. Now what we're going to do is we're going to move x squared plus 7x equals 2. In other words, I just moved the 2 over and I flipped them around, so it makes it a little bit easier to read. Now what we're going to do is we're going to take half of 7, so half of 7 is 3.5, and square it. 3.5 squared is 12.25. So x squared plus 7x plus 12.25 equals, well, 12.25 plus 2 is 14.25. And now what we're going to do is we're going to have to find a perfect square trinomial for this. And you might be confused by this. Just recognize that it's 7 divided by 2, which is 3.5. So it's x plus 3.5 squared equals 14.25. And now what we're going to do is we're going to take the square root of these two terms. So we're going to take these two out, and then we're going to get x plus 3.5 equals plus or minus the square root of 14.25. The square root of 14.25 is, put it in my calculator, about 3.775. And now let's just solve this out. X equals negative 3.5 plus or minus 3.775. And these don't look similar. But let me just assure you that the square root of 57 plus negative 7 divided by 2, this answer goes to about 0.275. And this other answer, I'm putting those in my calculator, by the way. Negative 7 divided by minus the square root of 57 divided by 2 is negative 7.275. And let's solve this other one out, because you don't believe me. Negative 3.5 plus 3.775. This equals about 0.275. 0.275. And our other one, negative 3.5 minus 3.775 equals negative 7.275. 275. So the difference of this versus this is this puts it in a little bit more of a rational state, a more exact answer, but this puts it in a more realistic and readable answer. So that's two ways of going about this: completing the square and quadratic formula. If we find a different example, you will find that completing the square is a little bit more difficult when we have an a term. We can still do it, but I'm not going to go into that. If you have an a term, you're better off just using the formula, because in order to do this, what you'd have to do is 6x squared plus 4x equals 6, and then you have to force a 6 out of this entire left side. X squared plus 4 sixths x equals 6. Then it just becomes an entire mess of trying to find proper things, and then you have to multiply by certain constants and everything. And it's overall just easier if you just put this into negative b over negative b plus or minus the square root of b squared minus 4ac over 2a. Memorize this quadratic formula. It's very useful, needless to say. Now, complex numbers. Let's go back to an example that we previously had. Let's go back to one right here. Y equals, where is this? Y equals x minus 2 squared plus 3. Y equals x minus 2 squared plus 3. And let's graph this again, shall we? You're pretty much good with graphing this. We already covered this. Plus 2 plus 3. Now, I told you that solutions for a quadratic formula are when the equation intercepts the x-axis, but this is never intercepting the x-axis. So why do we say there's no solution for it? Well, watch what happens. X minus 2 squared equals negative 3. And then when we go to the next logical thing from completing the squares to take the square root, suddenly we're taking the square root of a negative number. But with complex numbers, we create the complex number I, which stands for the square root of negative 1, to give some life to these answers and make them real. So now what we got to do to make them not real, to make them simplifiable, I have to be very careful because these are actually called non-real numbers, unreal numbers, imaginary numbers is what they're called. This is called an imaginary unit versus real units, which are like square root of 1, square root of 2, and so on and so forth. These are real units versus an imaginary unit. So that's why you got to, when you're specifying your domain, you got to be careful to use the term reals, not all, because not all numbers work, only real numbers work. But at any rate, we're going to actually use imaginary unit I. So then it becomes a matter of I times, it becomes a matter of I times the square root of 3 is our answer. So then it becomes plus or minus square root of I, and then it becomes x minus 2 equals plus or minus the square root of I root 3. And then we add 2 to both sides, so it becomes x equals 2 plus or minus the square root of 3i times the square root of 3. And that is our solution. We have complex numbers, and we've used them to simplify our equation. Now, there's some pretty unique things about I that you're going to want to realize. I squared is actually negative 1. Why? Because it's negative 1 times negative 1, which equals negative 1. So it's two negative 1's being squared together, and I squared therefore equals negative 1. And there's other properties such as that. Every time I becomes a even number, it can be translated into so on and so forth. Alright. I believe we've covered everything we have to cover today. I'll see you in the next tutorial.